So optimization problems. Okay, so what does optimization mean? You've done this in high school, I think, a bit, optimization, but what does it mean? Okay, so optimization is really just finding the the optimal solution, or the, let's say, the max. We're always looking for maximum or the minimum. Okay, of a function. Okay, so we've done so far, we've done finding the maximum and the minimum of a function on an interval. So now let's apply this on the problem. Okay, so I'm going to give you a word problem. You're going to have to find what is the function we're trying to maximize or minimize. Okay, so here's an example. Okay, so these get a bit tricky, but if you follow my process, you'll be fine. So a rectangular field is bounded by a fence. So let's start with this. A rectangular field is bounded by a fence. Okay. So there's a picture. So let me draw a picture for you. Okay. So as shown in the picture. So let me draw it. It's like this. Okay, and okay, so this is going to be the field, and I'm going to explain what this is. Okay, so this here is a building. And this measures 20 meters. Okay, and here, this is a river. Okay, so obviously, I don't need a fence here, and I don't need a fence here. Okay, so these are already fenced for me. I just need a fence here, here, and here to enclose my rectangle. You understand? Okay, so again, because you're writing, I think, I need to fence off this rectangular field, but I don't need a fence here because there's a river, right? If I have animals here, they won't escape. And there's a wall here of the building, so I don't need a fence here. So I just need a fence here, here, and here. Okay? So the question is, find the dimensions of the field with maximum. So here's your optimization question. Maximum, right? Or maximize area that can be enclosed with 1,000 meters of fence. Okay, or fencing. Okay, so obviously no fencing needed along river or building. this is my problem. This is what I need to solve. Okay, so this is a real problem that could really happen. Okay, so you have 1,000 meters of fence at your disposal. $1,000 meters. And so now you have to decide what shape of rectangle will you put here to have the maximum area here for your animals. Okay, so let's start. Okay, so I'm going to do this one, and I want to let you try one on your own if you can. So the first thing I want to do is I'm going to label the dimensions of my field. Okay, so I need fencing here. So this I'm going to call X. And the other dimension here is what I'm looking for. I'm going to call Y. Okay, this will be what here? From here to here will be how much?
X minus 20.
Good. X minus 20. Okay. So right away, what do I know? I have 1,000 I have 1,000 meters of fence. So I know that X plus Y plus X minus 20 has to be 1,000. X plus Y plus X minus 20 has to equal to 1,000. Is that okay? Okay, so this means that 2X plus Y is equal to 1,020. Okay, good. Or if you prefer, Y is equal to 1,020 minus 2X, and this is a first relation that I have. Any questions? Okay. So now the question is, what do we want to maximize? We want to maximize what? The area, right? So the area. And what's the area? What's the area of this field? X times Y. Is that okay? Okay. Now, I'm maximizing here an area, a function that has two variables. I've never learned this. Okay, this is, you would do this in calculus 3, but there is a way here to express everything in terms of X by using this equation we just found. So A is X times Y, which is 1,020 minus X. And so it's 1,020X minus X2. This is what I need
minus
to...
2X.
Sorry?
It's minus 2X.
Oh yeah, thank you. Minus 2X minus 2X. So thank you. Any questions? Okay. So we need to find the maximum value of this function. So I need to decide over what interval. Okay, so because I want to translate this into a problem just like we did yesterday, 2 days ago. Or yesterday. Okay, so what are the possible values of X? Okay, so what is the lowest value that X could be?
0?
No, it can't be 0, because if X is 0, then this would be negative.
Oh, yeah.
Okay, in other words, you're not going to use, you're going to use this wall. You're not going to use all of the wall. For sure, X is at least 20. or else you're not using some free fencing that you have there. You understand? Okay, the wall, we're going to use it as fence. So X is for sure at least 20. Now, what is the maximum that X could be? Can you tell me what's the maximum that X could be?
1,000.
Could it be 1,000? 500? 500? So 1,000 it can't be, because if this is 1,000 and this will be 980, then that's a little bit too much. Okay, so the worst case that could happen is if Y is very, very, very small, and then X becomes very, very big. Right, you understand? Right, if your field is like this, I'm going to erase in a second, but if your field is like this, you understand? You can make a field like this. You would have used
Oh, 490,
how much?
490.
490. I think I have more than that, no? If X is 490, so what are you using? Let's say Y is 0. We're closing it completely. So 490 plus 470. So we just used 960. So basically, what I would do is, just erase this.
Sir,
Yep.
just a quick question to make sure I understand. The minimum is 20 because if we had anything less than 20, then the X minus 20 would be negative.
Exactly.
Okay, thank you.
And if you want to understand it in a more real life sense, not a mathematic sense, mathematically you're right, but if you understand really, is that if X is, let's say, 5, nobody stops you from putting X is 5, okay? If X is 5, then your fence, you'll do it until here, let's say, and your field will be like this. You're going to have a big Y and a small X. It works too. The problem is that you're not using this. You're losing some free fencing, and that's for sure not going to be the best solution. Okay? Okay. So what is the maximum value of X? So for here, I would put Y equals to 0. So we're going to put Y equals to 0 in here. It means that when Y is extremely small, how far could X be? So 2X is equal to 1020, and so X will be 510. This is the maximum possible value of X. It cannot exceed 510.
So I have a question.
Yeah.
Would it be like open brackets? Because we know obviously Y cannot equal 0. So why are we including the 510?
Why are we including 510?
Yeah, if that's impossible.
It's not impossible. Oh, yeah, it's not impossible. Why is it impossible?
For Y to equal 0, that means the field doesn't exist.
It's just closed. The area is 0. The area, it's a field with an area of 0. You're still using your 5,000, your 1,000 meters of fence. You're using it, but for nothing. You're just putting 2 fences stuck together for 500 meters. You understand?
Okay. Yeah. Okay. Thank you.
Okay, but it's a good question. Okay, so basically we need to find the maximum value of this function on this interval, and this we know how to do, right? What do we do here? I'm just going to write this. I'm going to write it under here so that I have space to finish the problem. Okay. Now, how do we find the maximum and minimum values? So remember, I found the A prime. So it's 1020 minus 4x, and I put it equal to 0, right? We've done this yesterday. And so if I solve for x, I get x equals 1020 divided by 4, 255. Good? And then I want to find the area at each of them. So area at 20, area at 255, and the area at 510 equals what? Remember? Sorry, it's crooked. Okay, so at 20, I'm going to plug in 20 in here, and I want to see what the area is. So 20 squared times 2 negative plus 120 times 20. 19,600 meters squared. Let's see at 255. 255 squared times 2 negative plus 255 times 120. I get 130,050 meters squared. That's pretty big. And then the last one, 510. Let's plug in 510 here, squared times 2 negative plus 1202 times 510. I get 0 as expected, like you said in your question. So this is the maximum. This is the maximum area we could create with 1,000 meters of fencing along that river and that building. Okay, so they wanted the dimensions, so we're going to find the y. Okay, so x is 255, and so y is, I just plug it back in here, 255 times 2 plus 1202 is 510. There you go. This is the answer.
Sir, can you explain logically what doing A prime in this problem does?
A prime, this here?
Yeah, right. Like in the problem, like in.
Well, because we found the function here that gives me the area. Let me just go back up here a bit. I know you guys are still writing? Okay. So just this function here gives me the area as a function of x. Okay, so if we want to maximize this area, so it ends up being find the maximum of this function. That's it. So it's finding the maximum of a function over an interval, and this is exactly becomes a problem like what we did last class. Do you understand? With the derivative, why do we do it? Because it finds for us the local extrema. This is why we do the derivative. Where is the slope of the tangent of this function? 0. Because that will give me a critical number. Remember this?
Yeah, I understand mathematically, but logically, I don't understand. That's my problem.
Logically?
Yeah, everything we're doing, like with all this stuff, I understand. It's just like my logic, the logic part, I don't understand.
What logic? Like how is this applied in life? You mean?
Exactly.
Oh, okay, so what is a derivative really? What's a derivative? It's really a rate of change. Okay, so what I'm saying here is that if you increase, let's say you increase a bit, you start x is 20, and then you start increasing the x, and then you're increasing again the x, increase, and you're thinking, if I increase the x, does it increase the area or not? And you're going to notice that the area will increase until you reach 255. As soon as the x reaches 255, then you'll see that the area is going to start to decrease again. Do you understand?
Yeah.
So if you were to do it without derivatives, okay, let's say you were to do without derivatives, you would do x is 20, what's area? X is 21, what's the area? And so on. X is 250, 254, what's the area? X is 255, what's the area? X is 256, what's the area? And then you will see that at 255, you will reach, it'll stop increasing and start decreasing again. Okay, so instead of doing this for each value of X, let's see when it increases or it decreases, we have a good tool called derivative that does it for us. And it tells me where the function is increasing or decreasing. Okay?
Thank you.
It's clear?
Yeah. Thank you.
Okay. So I think you guys are ready to try one. Okay, so let me set you up with another question right away. Okay. So maybe the same type. Let's do the same type of question so it registers. So a farmer, again with the farmer, wishes to enclose a rectangular field by a fence and divide it into two parts by another fence parallel to one of the sides. What is the dimension what are the dimensions of the largest area? So pretty much the same question that can be enclosed. By using a total of 1,800 meters of fencing. Let's do it. So I'm going to call this X, 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 y, 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 y. And the total fencing is 1800. So 3x plus 4y equals 1800. And so y is equal to 1800 minus 3x, all this over 4. Okay, and so y is 450 minus 3/4 x. Questions? Okay, so that's what I know. And we want to maximize the area. So we want to maximize the area, which is A equals x times 2y, right? So x times 2y, which is x times 2 times y, which is this, 450 minus 3/4 x, which is 900x minus 3/2 x2. Here's my area that I need to maximize. Questions?
Sir,
Yep.
why don't you consider since it says it divides either it could divide it either no, it could divide by being parallel to one of the sides.
Yeah.
Why don't we consider it the other way, for example? I know it's going to be longer, the fence, but
It's not gonna be longer, it's gonna be the same thing. If you would have cut it here,
yeah,
so you would have got y here, then you got x, 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 same thing. It's the exact same problem. You understand? It
no.
doesn't change anything. I don't know if that answers your question.
No, I don't quite understand.
Okay, what's wrong?
I'm saying we considered the fence that divides it into two parts vertically. What if we considered it horizontally?
I don't know if it's horizontal or vertical. I put the field like this. Look, now look. Now it's horizontal. What's wrong? If I turn the paper, you're happy? You got
No,
something?
because what I meant is that it says either parallel to one of the sides, you know, so like it could be also parallel to the two y's.
Okay, the same thing. Does it bother you that the field is like this instead of like this, or does it bother you that I call this x and this y and y x? I don't understand. What difference does it make? What do I call the sides? It's the exact same problem whether I cut it here or here. It's the exact same problem. Don't get tricked or fooled by the orientation of the rectangle. I drew the rectangle like this. I could have drawn it like this and cut it. It's the same thing because I just drew a generic rectangle because I don't know which one's going to be longer. You understand? Maybe y is going to be much shorter and x is going to be long. I don't know. It's not clear.
I kind of get it, but
Kind means no. It means you don't get it. What's wrong? Tell me what's wrong.
just do it, and then at the end, if I don't understand, I'm gonna ask you again.
Okay. Okay, but
Wait,
please
so
ask. Yes.
like when I did it, I just made like two y's. I didn't separate the y's in half. Would it still work or no?
You did what? Y, a big Y here,
Yeah.
and then you put an X here?
Mhm.
I think it should work, yeah.
Get the same answer.
Yeah, it should work.
Okay.
Yeah, sir, I did that and it worked.
Yeah, it's gonna work as well.
Sir,
Yep.
Could you just please re-explain why the area is equal to x times 2y?
Oh, because what I did is I called this y and y. Actually, I'm wrong because I assumed that this cuts it exactly in the middle. Okay, which nobody tells me. Okay, but nobody stops me also from cutting it in the middle. They say you got to cut it somewhere parallel to the sides. No matter, it doesn't matter where I cut it. So I decided to cut it in the middle. Okay, so it's still right. Okay, but I don't need to make this assumption. So now if I assume that this is x, this is y, and this is y, so what's the area of the big field? It's x times this side. So right.
Oh, I get it. Yeah. Okay.
Good.
Thank you.
Okay, so now what are the possible values of x? What's the smallest that x could be? Well, x could be 0. Okay, if x is 0, then the y will be very long. I'm going to use 900 and 900, right, to get the 1800 of the field. Okay, and what is the maximum possible value that x could be? Can you tell me?
1,800.
No, you can't. If it's 1,800 here, 1,800, 1,800, you have 5,400 of fencing. You don't have this. You only have 1,800 maximum of total fencing. So each one will be how much?
600.
How much? I didn't hear.
600.
Yeah, 600. X cannot be more than 600. If x is a little more than 600, then we're going to use more than the 1,800 meters of fencing that we had. Okay, and that's it. So now it becomes a regular problem. Maximize this function with these on this domain, okay, or on this interval.
I don't understand how you found the 600.
The 600, well, the way I did is I put y equals to 0 here. And so 3x has to be 800. Let's say you don't use up any fence for the y. All the fence you use up for the x's. Of course, you're going to have a very closed, completely closed field. And you're going to have 3 pieces of fencing close together, 600 each. That's what it
Okay,
says.
thank you.
Okay. Okay, guys, the only way that you're going to understand is if you keep asking questions like you're doing now. Okay, go ahead.
So your method only works if it's exactly cut in half, right?
No, not necessarily. Not necessarily. Why do you say that?
Because you made y equal to each other. Like
Yeah.
you made the.
Yeah, but the y that I'm going to get, right? The each y that I'm going to get will give me the case if it's cut in half. But the total y will still be correct. It'll work for your answer as well.
Oh, okay.
Okay.
I see.
All right. So now, yeah, you're good. I could go on like this for the whole class. Even if we don't finish the problem, I just answer your questions. I'm happy. All good? No question? You all going to sleep good tonight? Okay. So what do I do now? Again, I do the derivative and then check at the endpoints and check at my critical number. Okay. So let's go. A prime equals 900 minus 3x. And this has to be 0. And if you solve this, you get x is equal to 300 meters. Right? That's what you got, right? And then we're going to do the a of 0, a of 300, and then a of 600. So I'm going to plug in 0 in here. I get 0. You're going to plug in 600 here. You're going to get 0. And you're going to plug in 300 here, and you're going to get this. I can't do mentally. So 300 squared times 1.5 negative plus 900 times 300. 135,000. That's what you found as an area. Meter squared. So obviously, this is your maximum. Okay, and so the dimensions. So if x is 300, means that y equals what? I plug in x in here, and I get 300 divided by 4 times 3, 225 plus 450, 225. And so the dimensions will be, so 300 meters by 225 times 2, which is 450 meters. Is that what you got? Yeah?
Sir, I got that, but my x's and y's are inverse. Does it make a difference? No.
Your x and all, what did you call the x? Is the x?
My x is my horizontal.
Your x
My
is
horizontal line.
this?
Yeah.
The x, x, x.
Add x, x, and then y, y, y. Yeah.
Oh, x, x, y. Oh, yeah, it's good. Of course. Yeah. Perfect.
All right. It won't make a difference if I try and graph it or anything, but my x's
No,
and y's
no,
are.
it's gonna be good. It's gonna be perfect.
All right.